Okay, so thank you all for coming back promptly from lunch. This is impressive turnout. Nobody lingered over the food and drinks. That'll be tonight. But I'd like to introduce Andrew Ryan from Facebook. And as he told me in the introduction, we got to hear how Microsoft does things this morning and a panel of a bunch of other companies doing things. And now we'll get to hear how Facebook does SRE. So.
Hi, everybody. So today we're going to be talking about the production engineering lifecycle, how we build, run, and disband great reliability-focused teams at Facebook. So my name is Andrew Ryan. I'm a production engineer at Facebook. I've been there since 2009. Production engineering is Facebook's reliability-focused, among other things, engineering team. Probably the closest analog to SRE that exists anywhere in Facebook. We started in 2009 with a handful of engineers in one office in Menlo Park. Now we are several hundred. We span 6 offices in 4 different countries. So things have grown a lot since we've been there. And over the past 7 years, we've had this incredible laboratory environment to grow teams and grow the organization and see what happens when teams grow and when teams start up. I've been fortunate or unfortunate, depending on how you look at it, to be the founding member of several different teams in production engineering, supporting a variety of services, from Hadoop data warehouse to our data cache team, and now currently on the Facebook traffic team, supporting our load balancing and global geo-targeting infrastructure. So I've watched a lot of teams start up, watched a lot of teams shut down, seen teams be successful, seen teams struggle, seen teams, kind of never really find their footing. And I'd like to think that I've been able to learn something from all those watchings and doings. And we're going to talk about what works, what hasn't worked for us over the years at Facebook today. So even though you don't work at Facebook, or at least most of you don't, hopefully you'll find some useful takeaways that you can apply to your own teams. So first of all, let's start by talking about what is a production engineer at Facebook. So 2 big things, right? Number 1, non-negotiable. They have to be good coders in at least one non-shell language, okay? And what we find is that most of our production engineers don't actually come from a strict computer science background. And that's okay, because most of the coding that we're doing is around automation, tooling, troubleshooting. It doesn't require necessarily a strict computer science background, but it does require you to know how to code. And then the other thing is a knowledge of real-world Linux, networking, distributed systems, right? This kills our recruiters because they're like, oh, wait, you need us to find candidates that are good at 2 things? It's like, coding and systems? But that's the reality of it. And in addition, most production engineers have some sort of a reliability engineering background, meaning that they've worked, if they have work experience, they've worked in a service supporting a production service, right? And they will be on call once they are production engineers at Facebook. Now their counterparts on the development side, Facebook software engineers, are primarily hired based on their coding ability, software design skills. They do have a variety of other skills, specialized skills, maybe it's file systems or databases or compilers or things like that. But what we do find across our software engineers is they usually don't have a explicit reliability engineering background, meaning that many of them have never been responsible for supporting a service directly in production. However, Facebook software engineers are on call. We do have a sort of policy at Facebook that says if you are responsible for a service, like if you write it, then you are responsible for supporting it in production. So this means we have a lot of teams that have a lot of engineers that are actually on call, in the line of fire, and have never really supported anything before, never really thought about the sort of discipline of operations or reliability. And this is going to come up a couple times more in this talk, but this is an important fact. And then lastly, I think it's worth spending a few moments talking about the operating environment at Facebook. So, as every organization does, we've built our hiring and kind of our team growing process around the environment that we work in. And that environment at Facebook is large scale, lots of data centers, lots of machines, lots of different diverse services and pieces of software, very rapid code and infrastructure change pace, and high growth rates that we've seen at least over the last 10 years. So a lot of challenges, not much margin for error. That's the environment that we're working in. So when we put all this together, we have our developers and we have our production engineers. Our ratio has historically and is currently around 10 to 1. So 10 developers for every 1 production engineer. There's a lot of reasons for that. I mean, it's probably the biggest one is that it's super hard to hire production engineers, and I don't really have a good explanation for that. It's probably another separate talk. But what this means in practice is that not every team at Facebook that has production services can get production engineering support, even if they want it. And it also means that when they get production engineers, teams don't necessarily know what to do with them. They don't necessarily know how to integrate engineers that are specifically focused on reliability and efficiency and performance and things like that. So because we're so scarce, this makes allocating production engineers really important. Where do we put this precious resource within Facebook to make sure that they're used most effectively? So our early approaches were based, where do we put production engineering teams, were based on, I would say, two different approaches. One is the hottest fire approach, where basically you say, what's the service with the worst reliability? All right, go there, right? And the other approach being the who screams the loudest approach, where whoever in the organization is yelling the loudest about how they need production engineers or something like it, let's give them what they want and put some production engineers there. So this had some problems. The biggest problems were that when we would put engineers in teams like this, the engineers themselves became single points of failure for a lot of these teams. In the sense that when we would put an engineer in a team, they would work and develop their own approach and hopefully mesh well with the developers that they were working with, but we couldn't really replicate their approach. I remember when I got to Facebook, I met with some teams and they were like, yeah, we've worked with Jack. Can you do what Jack did for us? And it was like, well, I know him and I can't do that. I'm not him. I don't have those skills. And what this meant was we weren't able to move people between teams without kind of collapsing the team around them, and we also weren't able to really replicate our success when we brought on new engineers. So what were the things that we saw when we did go in with these approaches? The first one was teams saying, oh, yay, we're getting production engineers, so here's all this broken stuff. Start fixing it. Second one was, yay, we're getting production engineers. Now we don't have to be on call anymore, and you can take over all of our monitoring and our dashboards and do all of our upgrades, right? Or, yay, we're getting production engineers. You'll be just like that team I had at my last company, and they did all these things for me, right? Or that team I read about on Hacker News that does all this cool stuff. And this is nothing against any other organization's SRE teams. As we've talked about, the teams themselves grow and become teams as part of a response to the environment that they work in. And our environment is different, so we couldn't be like those teams, those other teams. We had to build our own identity within the context of the Facebook environment. So we had to say a big fat no to the way we were doing allocations, the way we were building teams, and kind of the way we were integrating with development organizations. So what we did is we developed a set of guidelines for engaging with development teams. In the next set of slides, we're going to go through those guidelines and how we built teams. And it's really important to note that as we go through this, along the way, at any point, we could stop. In fact, we could just say, you know what, we are not going to engage with you. Even if your service is really broken and has a lot of reliability problems, we just can't support you right now. But come back in 6 months or 12 months and we'll talk again. So being able to say no, I think, is a really powerful weapon in terms of building good teams. So the first step in building a successful PE engagement is ensuring an understanding of the skill set. As we talked about earlier, there's a lot of software engineering teams that have really no experience themselves running production services or no significant experiences. We found the most important thing for them to know about our production engineers was that they can code, and in fact they're usually pretty good coders. But it wasn't enough for us just to go into development teams and say, look, we can code. What we found that we needed to do was actually bring the software engineering teams into our hiring process. So at Facebook, every single production engineer's on-site coding interview is done by a software engineer. And what this does is it makes them involved, it makes them a part of the process. They'll come then to our hiring meetings, and they understand what we're looking for in terms of our overall hiring process. And this means that when they get a production engineer in their team, they know that it's somebody that's been vetted by software engineers, and they feel a lot more comfortable with their skills and with their coding ability. And the other thing I suggest here is that you really make sure that you're sharing and publicizing the successes that you have as a team, as a production engineering team. When you disseminate the stories about your success to other teams in the organization, not only does it raise your profile, but it increases the understanding of what it is that you're trying to do. The second step is to understand the service or the software that you're supporting. And to do this, we've used a maturity model. You're probably familiar with general software maturity models. Ours is a little bit simpler, a little bit different. So on the software side, on the bottom there, we divide roughly 3 levels of maturity. From the initial build-out stage, where you're just kind of getting something off the ground, to the initial deployment, where you're starting to launch at small scale, beta maybe, and then finally where you're fully productionized, large scale. But what we saw is, especially in the early days of Facebook, it wasn't uncommon to have huge production services running on thousands of machines that had enormous gaps in their operations, meaning that they had large gaps in their monitoring, very little idea of how to further scale out their infrastructure and make efficient use of existing resources. And this is where the production engineering maturity comes into play, where we have this initial bootstrap environment where we start putting in processes, getting monitoring in place, up to the scaling where we figure out ways to scale our service more efficiently and better. And then finally, what we kind of call the awesomeize step, where we're really extracting the last few percent of reliability, the last few percent of efficiency out of a service. So we ask questions. We ask questions, like, what are your big problems? Or how often does your service go down? What kind of errors are you seeing? What kind of latency are you seeing? What kind of latency do you want to see? And we kind of get a sense of where it is on this spectrum that the service lies. And this is really important for us to not only know what it is we need to do, but also what kind of engineers we need to bring into the team to make them successful. Because what we find is that some production engineers are better at the sort of bootstrapping phase, while other engineers are better at the sort of awesomizing last few percent phase. And getting the right people on the job is really important. Next step is deciding on the level of engagement. it's important to know that not every engagement of production engineering needs to be a full team. The software engineers that we're working with, even if they lack real operational experience, they're real smart people. And very often they don't need a lot of instruction in terms of how to make things better. So sometimes what we find is that even just an advisory role of having one or two engineers meet with the team on a semi-regular basis is enough to get them pointed in the right direction and started on the right path to getting themselves in a place where they're a lot better off. One step above that is what we call the consulting role, where we'll have, a couple of production engineers working part-time on real deliverables, but they're not actually full-time on the team. It's just, maybe a little bit more of an effort. Finally, there's the full engagement where we would have a dedicated team, a couple engineers, 6 or more if on-call is needed generally, and sort of that would be like the full team setup. But that's not the default, and we'll work with the team to make sure that they understand what's needed. Next, we've got assigning the most suitable engineers. Now here, we want to be balancing between personal growth, business needs, and existing skills. So your engineers are going to be good at lots of things, maybe not so good at other things. You want to make sure that you get the best people for the best job. Even though we're typically hiring generalists, it's still, there's still specialties within generalists, and you want to kind of get the best people for the best job when possible, right? And on this point, I think it's really important to, I know this has come up already today, sitting the production engineers and the developers together. What we've found in our experience is that any physical distance is bad. Even if it's like down the hall in the same building, still bad. It leads to more miscommunication, more mistrust, just sort of a general lack of efficiency. So sitting the developers and the production engineers right next to each other, I think is really important. I know it's not always possible because sometimes teams work in different offices, but whenever it's possible, you should do it. Even if it's just a couple days a week, we have some hotel desks or some space where they can come and collaborate together, helps tremendously. So the last step for successful P engagement is actually splitting up the tasks and on-call work. And this is where the rubber meets the road, right? All the other stuff is well and good, but when it actually comes down to divvying up the tasks and the roadmap items and deciding who should be on call, that's usually where things get tricky. And we've spent a lot of time on this throughout the years. So for dividing up task work, we use this metaphor based on Maslow's hierarchy of needs. So Abraham Maslow is a sociologist that developed this sort of pyramid structure, which you've probably seen before, starting with the idea that if people don't have food and a roof over their head, they're not going to be thinking about things like social needs or love or whatever. You need to get those sort of basics out of the way before you can think of the more advanced stuff. So we've kind of adapted this for production engineering into kind of a basic hierarchy of needs that we've put together for production engineering, starting with server hardware and provisioning, going up through server monitoring, service monitoring, lifecycle, all the way up to like the really weird stuff that only happens once every year, but still is important. What this has allowed us to do is to prioritize. When you get a long list of tasks and roadmap items, what do you do? What order do you start doing it in? The service pyramid tells you that, right? You just look at where do these things fall under the pyramid. You do the basic things at the bottom first. One of the great things about the service pyramid is that it's adaptable for lots of different teams. So this is a sort of generalized one, but let me show you one from one of our specific groups at Facebook. This is actually part of the traffic team at Facebook where I work now, something called the Facebook Network Appliance, which is some hardware that we ship out to certain ISPs that effectively functions as like a mini POP. But we don't own the physical space where these machines are deployed, so security of the hardware is extremely important. So in the FNA service pyramid, you see security is actually part of the base pyramid, because if our boxes aren't secure when they're shipped out and all the way through their life cycle, the rest of anything that we do is not going to work. So security is really part of that base platform. And then you'll see some other stuff. You know, we put our CDN infrastructure software on there. But it's just proven to be a really nice, simple metaphor for deciding what's important and who should do what when it comes down to splitting up the tasks. Next is on-call. And probably nothing that I've ever seen, you know, in any company engenders as much kind of bad feelings and emotion as on-call. So when you're thinking about where to put in a production engineering team or individuals into on-call, really you want to step back and take a deep breath before just throwing bodies into an on-call rotation. I think when we're doing on-call planning, we follow these 3 simple rules. You know, you want to avoid burning out your engineers, but at the same time, you need to keep them sharp, right? So you don't want to have too much time on call, you don't want to have too little time on call, and ideally you want to have your engineers doing what they're best at as well. So, okay, how do we actually use that to decide who should be on call? The next part of this is understanding what it is your on-call load actually is comprised of. Again, on-call is often an emotions-driven decision. Try not to make it that if you can. Understand where your actual issues are coming from and how urgent they are. So for example, using these axes of urgency and code and infra, you might just, you know, see where the bugs are happening, where the tasks are happening, and decide how to build your on-call rotation and integrate that from this data, not just from people's emotions. So there's 3 ways that we integrate production engineers into on-call rotations. We'll talk about those now. First one is what I call the mixed rotation. And this is when production engineers and developers actually come together into a single on-call rotation. You know, meaning that, let's say you may have a rotation of, you know, 6 or 7 or 8 engineers, and it could be a PE one week, a software engineer the next week, a production engineer the next week, a software, you know, whatever, back and forth. And this works really well in our experience when you have a sort of medium amount of complexity in your service and a moderate volume of issues. It also works really, really well in the sense that it makes the software engineers, the developers, and the production engineers on equal footing. I think it's really good for developing a sense of team and a sense of sort of oneness, right, with the different engineers, because they're all on the same on-call rotation, and that's great. Disadvantages are that it doesn't scale to a team size of probably about 12 is where it kind of breaks down. Why does it break down at 12? Well, after assuming about a 1 week on-call shift, which is pretty typical at Facebook, if you have a larger rotation than that, now you could only be on call once every 4 months or something like that, which is just not enough time to be on call. It's not enough, you know, experience. And then the other thing is that engineers are often not working at what they're best at, right? So production engineers who aren't super familiar with the code of the software or new features might be getting all these code bugs, while software engineers who aren't as savvy on the infrastructure might be getting all these infrastructure tasks and may not be always most efficient at solving them. So that's when we bring in the second type of integration, which is the separate rotations. In this, developers and production engineers are in separate concurrent rotations. And we'll use this when we have high complexity, high issue volume, and more than 12 engineers on call. So it's complicated, it's big, it's kind of hairy, but it works really, really well for allowing teams to scale pretty much unlimited size to any number of on-call rotations needed to support a product. as a real-world example of how we've implemented this, this is from our core data cache team, where we actually have 5 concurrent rotations at any one time supporting our caching. So we have Tau server and Memcache server, which are 2 cache server products. We have the production engineering cache team, and then 2 other rotations for cache client and McRouter client, which are 2 cache clients, PHP, and McRouter is C++. So in this scenario, there's 5 separate on-calls. Each on-call has its own service level alarms, and then there's also some umbrella, call them oh shit alarms, like, data center, it's taking 1 second or more to get every cache request. Something's really, really wrong. We don't know what, but everybody needs to get, all hands on deck and come and fix it. And the on-calls are constantly coordinating with each other during shifts. Of course, during, using split rotations, you end up dropping some issues or misrouting some issues. It's not perfect, but it's the best way to scale when you have a lot of teams and a lot of engineers that need to be on call. The third way we integrate on call is to actually don't be on call. Sounds great, right? Sign me up. But what we've seen is that in some cases the service or the software is just not supportable in the sense that, so for example, once I started working with a team and they're like, well, what do you do on the on-call rotation when you get this task or when you get this alarm? And they're like, well, you go down the box and you GDB it and you start tracing the threads. And I was like, well, we didn't write the software. We can't do that. So you're going to have to give us some tools that'll help us, before we can do that. And this can be used as a sort of carrot or stick for a dev team that has really not gotten their act together to such a degree that they can actually allow other people to be on call. And it's a really powerful motivator, saying like, hey, you'll get a couple new engineers in your on-call rotation once you document your service or once you give some basic tools for being able to manage your service. And it's been useful for us. But you want to get on call as soon as possible. Not only because on-call is so much fun, but reliability is a muscle, and if you don't use it, I think you lose it. You lose the on-call edge, and that's not a good thing for us. So we're all familiar with the challenges of integrating teams across multiple time zones, more meetings, meetings at awkward times, management challenges, etc. Sometimes the engineers in multiple time zones are thrust upon you, so you don't have any choice. But if you do have a choice, one of the sort of criteria that you would use is when are your issues actually happening. So you might add another axis to that graph we saw before, where now you're actually looking at time as well as just the urgency and the type of issues. So in Facebook, there are not very many production engineering teams that are split across time in terms of sharing a rotation. 3 that are the network infrastructure production engineering team, the MySQL infrastructure production engineering team, and the web foundation team, which are all very, very key, very broad teams within Facebook that have to have a super high, their super good response time, and what they're supporting is super critical. But they're really the exception rather than the rule. Most of our teams are staffed out of a single location or single time zone. So finally, let's talk a little bit about disbanding emerging teams. You may think of disbanding a team as kind of a failure, like, this team was just bad, it was throw it away. But sometimes you just don't need it anymore. You may have achieved your reliability goals. You may have stopped developing the software. Maybe it's at a stable place and you don't need production engineers anymore. Or you may move down that ladder of engagement. You may move from a full team to sort of a consulting or advisory role. And so I really encourage everyone to think of disbanding teams as kind of a healthy thing, not necessarily a bad thing. Because those engineers also go out into other teams and become successful and innovative in those teams as well. They take their experience, they apply it in other teams, and everyone's the better for it. So just to wrap up, I've got kind of a couple of things that I thought would be good, just put down. So things that we failed in the last 7 years or so, you know, this field of dreams approach where you just throw a bunch of production engineers in and say, okay, and a bunch of developers and say, okay, go work together and make a reliable service. Doesn't work. You need a deliberate, measured approach to building these teams and building this reliability. When you separate teams by time and space, that's bad. When you leave people in teams for too long, we try to move people around between teams every 2 to 3 years, and that's worked really well for us. When people stay in a team for too long, they get stagnant. The team gets stagnant. And sometimes, in fact, an entire team just gets unhealthy, and you just need to blow it up. And that's not, again, not necessarily a bad thing. One other thing that is a failure, I didn't talk about it in the talk, but putting senior hires in as tech leads has been, right away when they join the company, has been a big fail for us most of the time. We found it better to let our new senior hires just sort of chill for 6 to 12 months and then take over a team. The challenge of learning all of the technology as well as all of the people and organizational stuff has been really, just seems to have been really tough for them. So that might not be your case, but it's certainly been our problem. And finally, a couple of successes that we've had. Hiring strong generalists has really worked well for us, for the most part. And maintaining those standards across all of our offices it's been a little traumatic at times, but I think overall it's really benefited us. Now when production engineers from anywhere in the world go anywhere else or talk to anyone else, they know that the standards, they know that the standards are there, and they know that they're working with, you know, colleagues that are just as strong, if not smarter than they are. Investing in the common reliability infrastructure technology, super important. So we have technology like for auto remediation, for monitoring, for service deployment. That's super important, not just from a efficiency point of view, but it allows team mobility to be greater as well. So it's been really useful for us. Having this consistent approach to running teams, like I've talked about today, really great. And then to co-locate these teams whenever possible, either in the same office, preferably in the same building. Not always possible, but when it is, you should do it. So that's everything I can tell you about production engineering in half an hour or so. I'll be happy to take questions. The microphones are in the aisles. If you have any questions.
Hi. You said you're like using SREs depending on their skill set. Mm-hmm. How do you assess that skill set? Is there a questionnaire, or how do you do that?
That's a great question. How do we assess the skill set of production engineers? There's no questionnaire. We're not that big yet. Usually managers, and we rely on our managers and our team leads to kind of know who's good at what or who might be good at what. So really right now it's just kind of an ad hoc process of assessing skills.
So no standardized like process or anything?
No, and usually the amount of people that are sort of in play at one time, like if I'm thinking, oh, I want to start up a new team, there's usually not that many people that I have to choose from where I couldn't do it sort of by hand. I mean, if we were like 10x or 100x our size, for sure we'd have to have some sort of better system for that. But for right now, we're able to do that by hand.
Okay, thank you. Last addition, how many production engineers do you have?
I can't answer that, I'm sorry.
Oh, come on, a range.
Yeah. Right.
How many developers have you got?
Yeah, they told me I'm not allowed to say that either. You can look it up on LinkedIn.
Thank you.
Thanks.